Hello everyone, and welcome to another bottled Sky Devlog. I've got another round of updates that I'm ready to talk about, along with my thoughts on how I've designed some new features. First up, we have a new enemy to fight. Codename, the Chomper. I've already talked in length about the things I learnt after making the hamster, which was the first enemy to be made for Bottled Sky. The main takeaway is that we needed a simpler enemy that is more suitable for a first encounter. I hinted at more designs in a previous video where I talked about flowcharts for enemy behaviors. I designed 5 in total, and the main rules I followed for all of these enemies is that they should only have one attack, but they should all have different ways to optimally approach. For example, the Chomper is a melee enemy, and since your only combat option at the start of the game is the drill, which is also melee, you basically have to attack first before it attacks you. Other enemy behaviors might encourage the player to take a less direct approach. For example, a ranged enemy will likely attack first, so you'll need to dodge its first attack, then follow up before it attacks again. Some key points to note here though is that the Chomper has a delay between when it starts its attack animation and when it can actually damage you. We call this attack anticipation, named after one of the common animation principles. This ensures that if you're actively trying to attack the Chomper, then you'll always hit first, assuming you don't miss. And if you're not trying to attack, then this animation signals the player that it's time to be evasive. Taking damage is a possibility here, but by the time you see your first Chomper, the player should already know how to use the movement controls, how to use the drill, and how to craft and use a repair kit, which is a healing item. It also doesn't do much damage, maybe about 10% of your health at first. Dying is also a possibility here, but I plan to keep the punishment for dying pretty low at the early stages of the game. I haven't yet decided exactly what happens when the shuttle runs out of health, but if I still consider this to be a tutorial stage of the game, then I will likely autosave often and reset the game to right before the encounter. Lastly, using the drill on any target should hold it in place, and it won't be able to respond until either it runs out of health and is destroyed, or you're attacked by a third party, or you cancel the drilling loop yourself manually. Since your first encounter with a Chomper will be one-on-one, once you lock your drill onto the Chomper, you've already won. All 5 of the early game enemy behaviors that I designed should function in similar ways to this before I move on to more complex designs. Moving on to a related topic, I built a new system that makes it easier for me to build enemy behaviors. This isn't really something you'll see in game, but I figured it might still be interesting to talk about. I call it the AI Brain System, and although it could be used for anything that moves, its main use is going to be for enemies and other NPCs. The system involves 4 main pieces: the brain component, AI states, behaviors, and transitions. The main purpose of this system is to make it easier for me to reuse existing code and rearrange behaviors without having to edit the code at all. The system starts with the brain component, which is attached to the enemy itself. The brain component's function is to get data from other systems, like knowing where it is, where potential combat targets are, when it takes damage, and so on. The brain component doesn't control how the enemy behaves, but it does hold a reference to its current state. A state might be called something like idle, or chasing prey, or attack anticipation, but a state is not actually responsible for movement either. A state holds a reference to a behavior, which is responsible for movement. A state also holds references to transitions, which we'll get into later. The state will send updates to the behavior every frame to determine where the enemy should move next, and the state will query all of the transitions to determine if the enemy should change to a different state. Why build it this way? Because what this allows me to do is to code a library of different kinds of movement, which then becomes hot swappable in the Unity editor. Initially, I might decide that the idle state should have access to a behavior that tells the object to not move and stay still, but later down the line, I might decide that I want a specific enemy's idle state to actually move in circles. So then I would just swap out the no movement behavior with the move in circles behavior. More importantly, one thing I noticed when I designed those 5 enemy behaviors is that all of them had very similar behaviors as a whole, with small differences to set them apart. It would be a hassle to keep duplicating code for each enemy that wants to chase the player when it is aggressive towards the player. If there is a bug in any code that I duplicate, then the bug would also need to be fixed in multiple places. Instead, this system cuts down on duplicate code and has the side effect that if players instinctually react to specific behaviors, then the consistency helps players feel like they understand the game better. Each enemy will likely still have at least one unique behavior that sets it apart from all the others. But if I don't need to code all of its other behaviors that are similar to what's already been made, then that saves me a lot of time. It's also harder to accidentally create bugs if you don't do any coding. It might sound weird to hear this from a programmer, but the best code is no code. Some behaviors even have parameters that I can modify in the Unity editor on a per enemy type basis, so even if I give multiple different enemies a dash attack, I can tweak these numbers so that the movement of the dash looks different for each enemy type. Each enemy also has a configurable physics controller that has a bunch of parameters that affect how it responds to movement commands. With this, I could make another enemy that has identical behavior to the Chomper, but still have it feel different, and I wouldn't need to write any code at all for the copied enemy. An example of a behavior would be this move towards prey behavior. We can ignore this first line of code because it's actually empty right now and doesn't do anything. A behavior has no awareness of the game world, so it relies on the brain component to figure out what is its prey and where it is. It doesn't even have awareness of other components that exist on the enemy itself. So first, the behavior asks the brain for access to its movement controller, and then asks the brain's prey awareness system what its current focus is. Now, the behavior has all the information it needs to carry out its function. With knowledge of its prey, it can get its position, then tells the movement controller to move towards that point. Then, there's one last line to make sure the enemy isn't spinning around, which can sometimes happen since there's no gravity in space and there are asteroids bouncing around everywhere. That's it. There's nothing else this behavior does. You might be wondering how it decides when to transition to another state. Well, let's get to transitions now then. Transitions are listed on the state rather than on a behavior, so let's go to the Chomper's chase prey state. It kind of looks like there is a lot to take in, but I'll walk you through it. Right here at the top is the behavior associated with this state. This confirms that the chase prey state is using the move towards prey behavior. Next is this big list of transitions. The number 4 here means that there are 4 possible transitions. To simplify this, let's look at just the first one. At the top, there is a reference to a transition condition. I won't dive into the code of this one. I'll just simplify and say that it checks if the enemy's health has reached 0. If this condition returns true, then we have a list of possible states to transition to. Normally, each option holds a reference to the state to transition to and a waiting value, which is checked with a random number generator that decides which state to transition to. This allows me to have some randomness when going from one state to the next. However, I'm actually not utilizing this randomness feature at all. Every transition has one possible state that it can transition to, so the Chomper's behavior is very predictable. I made it because it might be something I'll use for future enemies, but I decided against having random states being a part of the Chomper's design. The next transition checks whether the enemy's prey awareness can still recognize a target. Currently, if the prey dies or moves out of range, then the awareness no longer keeps track of it, but it does then shift its focus to another target if it had any secondary targets nearby. If there are no more prey targets to be found, then this transition returns true, and the Chomper returns to its idle state. The third transition checks if the target prey is within a specific range and if the enemy is facing its prey. If it meets these conditions, then it transitions to the attack anticipation state. If I check the transition itself, there are parameters that decide how close the enemy needs to be to its prey and how closely it should be facing its prey. The last transition checks whether the enemy has taken damage recently, and if that returns true, then the enemy moves to this taking damage state, which currently just plays a stagger animation and then moves back to what it was doing before. After the transitions, there are some more options on the state to play a specific animation and audio event when the state is started. That pretty much sums up the AI brain system. We'll see in time if this ends up actually making the whole enemy creation process faster. Now back to something that players will actually see, or rather hear. The new sound designer has been hard at work making a variety of sounds across all areas of the game. Here's a little montage of some of my favorites. Everything is sounding a lot more juicy. I love it. Finally, the last thing I want to talk about is a new system for placing hand-created assets into the background. Before this system, there were only parallax layers of these cloudy, starry, paint blobby shaders I made. It looks great and all, but it was still missing things, for lack of a better way of describing it. As in, we can see lots of interactable stuff in the foreground where the gameplay happens, and there's clearly lots of stuff far away, but what exactly is all the stuff in the background? This system provides an answer to that question. Currently, I have only added a single asset, which is being randomly placed, rotated, scaled, hue shifted, and whatever else you can think of. The artist has made 70 or so different assets, but I'm going to make it their job to add them all into the game. This system is generally intended to be more of an aesthetic only thing, but it could be expanded to have interactable elements in the background. At some point in Bottled Sky's history, before we restarted development, you could explore planets like these by flying roughly over their position, and you would then see a prompt to go and explore it. Something like that will likely make a return, but in what form, it's hard to say because I don't want to spend forever developing this game. Alright, that pretty much wraps up all I have to say about this month's progress. As always, if you enjoy these videos, then consider interacting with the like button to appease the algorithm, and subscribe if you want to be notified about future videos. If you have questions or feedback about the game, then leave a comment either in the comment section below or join the community Discord server. You can find various hyperlinks in the video description. Thanks for watching, that's all for now, and I'll see you later.